Hi guys. In this video, we're going to focus on what those phrases meant that we were writing when we found the discriminant. So it's all good to find the discriminant and to memorize a phrase, but if we don't understand what the phrase means, it's kind of pointless. So that's what we're going to talk about in this video. I'm going to use the same examples that we did from the first video, and I'm going to show you visually what it means, and then I'll show you what it means for getting a final answer. So let's start with our first example from our previous video. In this example, we discovered that the discriminant was 36, and we stated that that meant that there were two unequal, real, rational roots. So let's break that down a little bit. 2 means that there will be two answers to this problem, which is what we were doing with solving by factoring, right? We were getting two solutions. Unequal means that the answers will not be the same number. Real means that there will not be a letter I, an imaginary number, in the answer. And rational means that the numbers will be nice fractions or whole numbers. In this problem in particular, when I solve it, I will get the answers, -1 and +5. So again, two answers, not the same number, not imaginary, and they're nice, pretty numbers. Now you can get fractions like 1/2 or 3/7 or something like that, but they're going to be pretty decent fractions. I'll show you on the next example what a not decent fraction looks like. Now, last week we also talked about how the word roots is another way of saying the x-intercepts of a graph. So let's take a look at what this looks like when we graph it and where we can find the solutions on a graph. Here I have graphed the equation from our PowerPoint. I had to change it from equals 0 to y equals so that it would graph on a coordinate plane. Now, if you remember, we said that the solutions were -1 and 5. So if we look at the graph, you can see that the graph is crossing the x-axis at -1 and also at 5. So remember that the solutions that we get is telling us where our graph is going to cross the x-axis. And so this graph is crossing the x-axis in two places that are not the same number, that are nice, pretty numbers, and that are real numbers. So that's what this means on a graph. Let's take a look at our next example from our first video. In this example, we got that the discriminant was -44, and the phrase that we used for that was two imaginary roots. That means that we will get two answers, but there will be a letter I in the answer. So it's going to be imaginary, the square root of a negative number. For this particular problem, when we solve it, my two answers will look like this. And I'll teach you on Friday how to actually find these answers. For right now, just this is what the answer is going to look like. So it is two answers because there's a plus or minus sign. So one version has the plus sign, 2 plus I rad 11 all over 5. And then the second answer has the minus sign, 2 minus I rad 11 over 5. So this is what the solution is. And then let's take a look at what that means for a graph. Here I have graphed the equation that we had just found the discriminant for. Now remember that we said that the roots were imaginary and that roots is a special way of saying x-intercepts. So that means that the x-intercepts are also imaginary. They do not exist. So in this problem, you can see that I have my parabola shape and that it does not touch the x-axis, and it never will touch the x-axis, right? It's not gonna like turn around and come back down so that it can cross the x-axis. So if you say that there are imaginary answers, that means that there are no x-intercepts. It does not cross the x-axis. Here is our third example from the first video. In this example, we found that the discriminant was 140, and we said that we had two unequal, real, irrational roots. Now again, 2 means there's two answers. Unequal means they're not the same number. Real means I will not have a letter I in the answer. And irrational means like my number is going to be crazy, horrible. Essentially, it means that there's going to be a radical in your answer, but it's not a pretty one. So here is, and this isn't even like as bad as it can get. But here's the solution for this problem. And again, I'm going to show you how to actually find this in tomorrow's video. So don't worry about trying to find it right now. But just note, this is what it would look like. And the fact that it has a square root still as part of the answer is what makes it an irrational answer. Let's take a look at what this looks like when we graph it. Here's the graph of this equation. Remember, we said this should have two roots, which means it crosses the x-axis twice, and it totally does. It's on these two dots right here. But notice when I hover over the dots that I'm getting a decimal answer. It doesn't even stop right there, right? Like this website is stopping it after the third number, but I'll tell you right now, it keeps going forever. Like this number does not stop. And so the fact that my roots are a crazy decimal, that's what makes it irrational. So two roots, two x-intercepts that are not the same number, right? It's a positive and negative, and those are not the same. And then they're irrational, which means a never-ending, never-repeating decimal. Or was that square root of 35 is what made these decimals. So that's what that one looks like. And then we have one more. Here is our last example from the first video. In this example, we discovered that the discriminant was 0, and we decided that that meant that there was one real double root. That means that if you solved it, you would have gotten the same answer twice. In this problem in particular, you got an answer of -1. Now, you would get the answer of -1 twice, so -1 and -1, but we do not write it twice, we only write it once. And afterwards, we write DR to stand for double root. So that means that this answer was gotten twice. So even though I'm not writing it twice, it does count as two answers. Let's take a look at what that looks like on a graph. Here's the graph of the equation. Remember, we said that the roots are the x-intercepts, and so you'll notice that in this picture, my graph is only touching the x-axis once, unlike our other ones where it was touching twice. So that's where we get our double root, and it's just a single number, the number -1. Okay, so that's what the discriminant does. That's what it tells us. And part of your homework tonight is going to be to identify what graphs are accurate based on what the discriminant is. So if you think the discriminant means that there's going to be two solutions, then you want to pick a graph that touches the x-axis twice. And if you think that the discriminant says there's only one solution, then you want to pick a graph where it only touches once. And if you think the discriminant says that there are imaginary solutions, that means that it does not cross the x-axis at all, and so you would pick something that does not cross. This concludes today's videos.